And welcome to my third video. So today we're going to be doing high square. So before talking about high square, I just want to say that I'm not a statistician. I'm not a mathematician, and neither am I a statistician. The last time I did mathematics was when I was 15, when I was in my 10th standard or 10th grade. So what I'm trying to say is that you don't have to be a statistician or a mathematician to do some of the basic statistics that I'm going to show you. Today we have computers, and computers do most of the statistics for us, but it's very important for us to understand the theory and the concept of the statistic so that we can go ahead with it. So with that, I'll just begin my video. So as I said, we're going to be doing high square. So what is high square? So high square, it's also known as the goodness of fit statistic. It is basically used to determine whether there exists a significant difference between the expected frequencies and the observed frequencies. So it's basically used when categorical variables are involved. So basically, high square is a statistic that you use when you are dealing with categorical variables. Now, for our understanding, there are two types of variables. There are many actually, but the two main that you need to know is categorical and continuous. So categorical, as the name suggests, are in categories like male, female. Gender is one type such variable. The other one is religion and caste and so on. So high square is basically used to test whether there is any statistical significance when we are dealing with categorical variables. Yeah, and so let's go to the data that we're going to be using. This is it data of one of my students. This is actually a study on cancer patients. Yeah. So one of my former students has done a study on cancer patients and and their mental health. So this is the data view, as you know, and you look at the variable view. There are a lot of variables over here. We are going to be doing a basic high square test. Yeah. Okay. So for this, we need to first we need to have two categorical variables. So here, one variable that we want to know that we have here is the current, no, the yeah, the time since diagnosis. Yeah, so time since diagnosis is something that we have. It's in continuous. Okay, it's not a categorical variable. It's measured in terms of months, and it's continuous. And the other variable that we'd like to look at is anxiety. Anxiety here is also continuous. So first we need to convert these continuous variables into categorical variables. Now, as I've mentioned previously, you must always try to use collect data in the continuous form. Later on, you can convert it into categorical. Okay, but if you collect the data in categorical form, you can't convert it to continuous. Okay, so always collect data in the continuous form. Later on, it can be classified into a categorical variable. So let's do that first. First, we go to analyze, then we go to descriptive statistics, we go to frequencies, and then we pull in time since diagnosis. So that's a continuous variable. We're going to pull it into this box, the variable box. And we don't need standard deviation. All we need is a mean, minimum, and maximum to give us an idea. Then we click OK. So here, if you can see, the mean or the average score, average time since diagnosis of cancer is 10.45. So 10.45 months. Yeah, so that's the mean. The minimum is 1, the maximum is 30. So now what we need to do is we need to classify this. We need to convert this continuous variable into categorical. Yeah. So what we're going to do is we're going to go to transform. Here you go into something called recode into different variables. So click on recode into different variables and just scroll down to time since diagnosis. Pull it in. So once it's inside the variable box, click on this tiny box over here which says old and new values. So click old and new values. So here you have this another dialog box that pops up. Here remember the mean that we found out was 10.45. So on an average it's 10.45. Now we can divide this into two different parts. We can say, so range here is 0 to 10. Yeah, so we'll call that 1. Okay, so why 10? Because 10 is the average. Now it's not necessary that you need to go by this. You can have multiple categories, but I want to just divide it based on mean. So one is 10, and the other one. So here you have to click range and then click 0 to 10 and then add 1. So that's number one. So we are telling the computer anyone who scored between 0 to 10, no, recode that as 1. And then anyone who's scoring, let's say 11 and above, recode that into 2. So 0 to 10 will be 1 and 11 through the highest would be 2. So now we click continue. Now here we need to click this and then name it. So we can say average time of diagnosis, AVGDGI. So the name should always be in short form. The label can be big. So we can say average time since diagnosis. And then we click change. Okay, so if you go to the output here, usually it shows execute, but sometimes it doesn't matter. So we just click OK. Now you can see, yeah, it's clicked, it shows execute. So it's been executed, it has been recoded. So now you go to the variable view and you see the new variable that we have created, average time since diagnosis. We have created a categorical variable. The first thing we need to do is reduce the decimals to 0. Here we just click the label value labels, and under value labels we say 1 is 0 to 10 months, and we click add. So we are telling anyone whose 1 is 0 to 10 months, then 2, 11 months or more, and just click add. Then we click OK. So we are telling the computer if anyone's 0 to 10 months falls under the 0 to 10 months category, they are 1, and anyone who's 11 months and more is 2. Then we go back to the data view just to check if the variable has been created. So you can see the variable that has been created here, average time since diagnosis. You can see we have created this variable from the continuous variable that we had. So now we have created the categorical variable average time since diagnosis. Now the other thing we want to create convert into categorical variable is the total anxiety. So the anxiety score of the respondents, it's in continuous form. So to know the mean, minimum and maximum, we'll go to analyze, descriptive statistics, frequencies, and we pull the anxiety, total anxiety 2. First we need to click reset because there's something already there. So total anxiety, we click that and then pull it into the variable box over here. We remove the standard deviation, we don't need that. Then we click OK. So on the output file, you will see the mean is 16.90. So that's about 17. So the average score of the respondent is 17. Minimum is 2, maximum is 34. This is the anxiety score of the respondents in continuous form. So you can see the data is in continuous form. Yeah. So now we'll convert it into categorical data or categorical variable. To do that, we follow the same procedure. We go to transform, recode into different variables. Now always remember to click recode into different variables and not recode into same variables. If you click recode into same variables, the continuous variable will be deleted. So don't make that mistake, because we need the continuous variable for performing other statistics in the future, like correlation or something like that, or even regression. So now we look into recode into different variables. Click on recode into different variables. Now again you need to press reset because there's already something there, and we select level of anxiety 2. We click on that and then we click old and new values. Now on old and new values, if you remember, the average score, the mean score is 16.90, which is 17. So we'd say 0 to 17 is 1. Sorry. And anyone who scores above 18 and above is 2. Yeah. So anyone who scored between 0 to 17 is 1, 18 and highest is 2. That's what we're telling the computer. We click continue. And here you need to label the name and label the variable. So we say average anxiety, AVANX. That's a short form for the name. You can't write the full form over there. In the label we say average anxiety. Yeah. And then we click OK or change. So once we click change, we click OK. You see the execute command over there that's come up. So that means we created the variable. We just scroll down and at the bottom we see the average anxiety. Now we reduce the decimals to 0 and here we need to add values. So here what we're going to say, we found that the average was 16.90, that's 17. So we say that value 1. So we've already said anyone who's 16, 17, 0 to 17 is 1. So here we say 1 is above below average. Yeah, technically the average also comes inside, but we can say below average. Yeah, and 2 is above average. So the 2 is above average level of anxiety. So 1 is below average level of anxiety and 2 is above average level of anxiety. It's understood. So we just click OK. Okay, so we told that to the computer. So now we have the two categorical variables that we needed: average time since diagnosis and average anxiety. Yeah, both of them are categorical now. Now to do the high square test, we go to analyze, descriptive statistics, cross tabs. So I'll just show that again. Analyze, descriptive statistics, cross tabs. So here we have the high square value hidden away somewhere. So that's that. So cross tabs, and then we take the average level of diagnosis in the column. Yeah, and the average anxiety will be in the rows. Then we click on something called format over here. Format, everything is all right. We don't need to touch that. We can go to statistics and we need to click something. High square is already there. CHISQ, that's the high square. There's something else called pi, PHI. Now what's the pi? Well, pi basically represents the strength of the association, okay, between the two categorical variables. I'll explain about that later. Just tick that as well, then click continue. Okay. Then in the cells part, we don't need column, we don't need total. We only need the row and the count. That's all we need. Click continue and then we click OK. Okay, now we go to the output file. So here, as you can see, the data is here. Now in the next part of the video, I'll tell you how to explain this high square video. Now we'll be interpreting the high square results. So before that, I think we need to export these tables into a text format because I can't zoom this. So we need to export it. So one of the other features of PSPP is that you can export the output as well. So click on File and there's something called Export. So click on Export and here you can save this file. So there's an option, there's a drop down box over there. You can click that and then you can save it in PDF, HTML, OpenDoc, so many other forms are there, or CSV. So I want to just save it as a text file, so TXT, so that I can just show you the results. So click on text file and name the file. We say output cancer data. Yeah. So we click save. So let's go to that file now. Yeah. Okay. So here's the file. We just click the file. So this is in text format. Now you can zoom in, copy paste into Word and whatever you want to do, you can do that. So we are only interested, the whole output file has been saved. So we are only interested in the high square results that you can see over here. And so yeah, so here are the results. This particular box is very important. So you can see this is the average anxiety, level of anxiety. This is below average and above average. And here are the respondents divided in terms of the months since they have been diagnosed. So just look at the number here, 10. So there are 10 respondents who have a below average level of anxiety and who have been diagnosed in the past 10 months. Yeah. And then there are 12 respondents who have been diagnosed for 11 months or more. Okay. So, and then you look at the above average column. Here you can see that there are 15 respondents who have been diagnosed in the past 10 months or so. And then there are only 3 respondents who have been diagnosed in the past 11 months or more. Yeah. So 11 months or more. Yeah. So, so you can see. So one way of looking at it is ignoring uh, the below average column and only looking at the above average column. Or the other way of looking is only looking at the below average column and not looking at the above average column. So there are two ways of interpreting it. I would say for now, let's ignore uh, what do you say, the below average column and only interpret the above average column. Yeah. So we can say, so we're going to ignore the below average column and just look at the above average column and say that a higher percentage of respondents, that is 83.33% of respondents, fall in the above average level of anxiety, okay, and have been diagnosed in the past 10 months compared to the percentage of respondents who belong to the 11 months or more category and have anxiety. Yeah, I know it's a bit confusing. I'll explain it when I am typing it for you in a separate file. So for now, we just know that there's a higher percentage of people in the 0 to 10 months category who have a higher level of anxiety compared to those who are in the 11 months or more category. Yeah, so that means if you are uh, if you have been recently diagnosed, that is between 0 to 10 months, you are more likely to feel a above average level of anxiety. Yeah, so recently diagnosed people are more likely to be more anxious than the people who have been diagnosed for 11 months or more. So the initial shock is tremendous. So that's what this particular statistic tells us. I'll explain it in detail when I'm typing it, don't worry. Now, so this is the result. But do we know that this is a proven statistic? Can we say that? Can we generalize this? So that's the power of statistics. Statistics allows you to generalize. You know, so with a sample you generalize. That's the power of statistics. So to know whether we can generalize this or not, we need to look at the significance value. So if you go down, so here's the high square value. You know, it's 6.06, and then you see something called the significance. You know, this is 0.022. So the significance value is 0.022. Yeah, there are two significances, one-tailed and two-tailed. It's always good to look at the two-tailed significance because it's more accurate and it's more authentic as well. Okay, so the significance value is 0.022. Now I'll explain how to interpret this particular significance for those who have not studied statistics, who don't know statistics. Okay, like myself, I'll just explain that. Then we look at the pi value. So pi value is another interesting statistic. What it tells and what it helps us understand is something that I'll also explain once we're done with this significance. So I want to open a small document which explains the significance value. I've just created a small PPT for better understanding. So here you can see, so what is significance? So significance are also known as a p-value. P is the probability value, you know, it's a probability value. So we want to know what is the percentage, what is the chance of error in these results, you know. So when we say P is less than 0.001, it means there's a 0.1% chance of error, you know, or in other words, when you minus it from 100, you get 99.9% accuracy. So what we're trying to say is that the chance of the result being accurate is about 99.9%. So it's very, very accurate. You know, the power of the statistical power is just increasing. And the word that we use here is the result is statistically significant at a very high level. So that's the word we use when we're writing, when we're explaining the statistic. Then we look at the other level that's also acceptable. P is less than 0.01, which means there's a 1% chance of error or 99% chance of accuracy. How do I say 99%? Because 100 minus 1, you get 99. So there's 99% chance of accuracy. Here we say that the result is statistically significant at a high level. Yeah, that's the general word that we use. Now the third level is P is less than 0.05. So that means there's a 5% chance of error or 95% accuracy. Yeah, because 5 minus 100, 95. So there's 95% chance of accuracy. It means that the result is statistically significant at a moderate level. Okay, so we use the word moderate level. Now, a lot of people actually stop with this, 1, 2, 3. That's the three levels of significance. But then in the social sciences, I've read some articles in journals where they accept a significance level up to 10% error, and that is 90% accuracy, because social sciences deal with human beings, and there's a higher chance of statistics going wrong because people don't respond properly, and there are so many other factors that can increase the chance of error, since human beings are that you can't statistics has its own limitations. So we accept errors up to 10%. So when P is less than 0.10, or when there's 10% error or 90% accuracy, we say that the result is statistically significant at a marginal level. So this is the lowest level, so when you get a significance at this level, it's a very weak significance, but then many journals and articles do accept this level of accuracy, especially in the social sciences. But if there is an error above 10%, then it's generally not accepted. We can't say that the results are statistically significant, because the error margin just keeps on increasing and the accuracy keeps on decreasing, from 99 to 95 to 90 and so on. So if there's like 0.15, so that's 15% error, we can't say that that is statistically significant, so that's about significance. If you have any doubt, you can mention them in the comments so that I can explain it more easily. Coming back to our results, so here you can see the significance value that we have found. It's 0.022. That means 0.022. So when you multiply 0.022 into 100, you will get the percentage of error and accuracy. So that when you minus 0.022, yeah, just take a calculator and 0.022 into 100, yeah, you get 2.2%. So there's 2.2% chance of error. In other words, the results are accurate by almost 98.8%, if I'm not wrong. No, 97.8. Yeah, 97.8% accuracy is there in this result. Yeah, so 97.8% accuracy. And what level of significance is this? We need to look at this chart that I just created. So here you can see it's so P is less than 0.05, so 5% error. So it's definitely more than 0.1% error. It's definitely more than 1% error. It comes under the 5% error category. So we can say P is less than 0.05 in this case, and that there is 95% accuracy. So meaning that the result is statistically significant at a moderate level. Okay, so that's a decent significance. So that means this result is statistically significant. In other words, it means that these results are quite accurate, and that even in a larger population, you may see the same results, So it means that if you have been recently diagnosed with cancer, you are likely to fall in the above average level of anxiety category. You are more likely to suffer from anxiety if you've been recently diagnosed with cancer. But as time goes on, 11 months and later on, you are more likely to be in the below average level of category. So that's the conclusion that we draw from this high square result. In the next part of the video, I'll explain how to write this result, in Word, so that you can maybe understand it much clearly. Yeah. Welcome back to the video. Now I've created a small table with the data that we had. Now you can formulate your own table, but it should have all the major information that you need. So I've created this table. If you want, you can use this method as well. Um, and then I've tried to interpret the data that we have here in the form of a table. Now again, you can use your own form of interpretation, but how I interpret it is we just ignore, as I said in the previous part, the below average, and we just look at the above average level of anxiety and see which category of these two respondents. One category is those who belong to the 0 to 10 months. The other category of the respondents are those who have been diagnosed for 11 months or more. We want to see among these two category of the respondents which group has a high above average level of anxiety. And so we see that it's this, just ignore the upper part and just look at the bottom part. You will see that 83.33 percentage, a majority of those who have an above average level of depression belong to the 0 to 10 months category. you know Only 6.7% are those who belong to the above average level of anxiety, but but they have been diagnosed for a much longer period. So a greater percentage of those who have been recently diagnosed fall in the above average level of anxiety category. Okay, so it's kind of complicated, but then it's also very simple. I'll just explain it in one sentence. I've done this over here. So the results in table 1 indicate the fact that a greater percentage, that is 83.3%, that a greater percentage of the total respondents who have an above average level of anxiety are those who have been recently diagnosed with cancer. So a greater percentage of those who have an above average level of anxiety are those who've been recently diagnosed with cancer. That's how you should. That's all you need to explain. It's understood that the lesser group belongs to the lesser percentage belongs to the other group, which is 11 months or more. So what it basically means is that if you've been recently diagnosed with cancer, you're more likely to suffer from anxiety, which makes sense, right? Because it's a shock, something that startles you. Now we want to know whether these results are statistically significant, and in the previous part of the video we found that the results are statistically significant at 0.05 level. So the significance value we found was 0.022, right? Which is, when you multiply this with 100, this number 0.022 into 100, you will get 2.2%, which is less than the 0.5% error which is less than the 5% error that we accept. So we say that the results are statistically significant at a moderate level. Why do we use the word moderate level? Because when you go back to this PPT that I showed you, when the level of error, when the accuracy is 95% and the level of error is 5%, we say the results are statistically significant at a moderate level. So we use the term moderate level. That's why we say, moreover, the result is statistically significant at a moderate level. P is less than 0.05. Okay, so that's how it is. Now the other part that I want to talk about is the pi value. A lot of people don't interpret the pi value. The pi value or the Karmer V, okay, both are similar. They both tell us, especially the pi value tells us the strength of association between the two categorical variables that we are studying. So we know that there is a statistical significant association between the level of you know anxiety and the time since diagnosis. So they both have a connection. There is an association and it is statistically significant. That means that the association is not by chance, it's not an accident. There is definitely an association between these two variables. And but now we want to know how strong is the association. How strong is the level of anxiety associated with the time of diagnosis. To understand that, we look at the pi value. The pi value is automatically provided there. You need to just click the box, the check box when you're doing the test, as I showed you. So the pi value here is 0.39. Now how do we interpret this pi value? To interpret the pi value, we need to look, there's a particular table that's available that will help you interpret the pi value. But then anything that's above 0.25 is considered to be a very strong association. So anything that's between 0 is 0.5. It's in the 0.5 level. We say it's weak. If it is 0.10, it's moderate. If it is 0.15, it's strong, and if it is 0.25, it's very strong. So anything above 0.25 in the pi value section is considered to be very strong. And so that's why we say that the pi value indicates that the association between the two variables is very strong. So it's greater than 0.25. Now there's a reference for this. I will put it in the description so that you can read it. There's a table, proper table that's provided there that will help you interpret the pi value. It shows how strong the association between the variables is. So with that, I would like to end this video. If you like the video, please like it and subscribe to my channel. And I want to do more such videos, especially statistics like ANOVA, MANOVA, then correlation, Pearson correlation, Spearman's correlation, and maybe even regression and factor analysis and all of that. But then I'll try and find some time to do that. If I find time, I'll do it. And so yeah, thanks for watching. And if you have any doubts, you can leave a comment in the comment section below. Yeah, thanks for watching. Bye.